Hello everyone, my name is Berk Alparslan and I will present you how phase contrast magnetic resonance angiography works with two MATLAB examples. First, let's begin with the definition of magnetic resonance angiography. The idea that blood flow velocities could be encoded by phase was first developed by Paul Moran in the early 1980s. Magnetic resonance angiography is a group of techniques based on magnetic resonance imaging to image blood vessels. Magnetic resonance angiography is used to generate images of arteries and sometimes veins in order to evaluate them for any abnormalities. Let's continue with the phase contrast situation. Phase contrast MRA is an example of a non-contrast MRA technique. Regular MRI uses both frequency shifts and phase shifts to record position of protons within the slice. While frequency shifts depend on an actively applied gradient, phase shifts are remembered by protons. Thus, if we can somehow program protons to remember their phase related to how fast they were moving, we can read that out later to determine the velocity. So, Paul Moran analyzed the phase effects on stationary and moving spins subjected to a pair of bipolar gradients as illustrated in the diagram left here. A stationary spin subjected to such a gradient pair will experience no net phase shift, but a moving spin will have a net phase shift proportional to its velocity. Two spins flowing at the same speed but in opposite directions will have equal but opposite phase shifts. By measuring changes in phase, therefore, velocity can be computed. This phase contrast MRI simulation will give you a sense of how phase contrast MRI works and how changing parameters will affect the image. Wank value here is velocity encoding, and by different values of velocity encoding we can see the effect on image here. For the working principle, there are two methods for PC-MRA acquisition, incoherent technique and coherent technique. In incoherent technique, two images are acquired, one with flow compensation and other without flow compensation. The subtraction of two images results in an angiogram. Two methods used for subtraction include the phase difference PD and other complex difference CD. Phase contrast complex difference PCCD angiogram is the image that shows the magnitude of CD vector as pixel intensity. Here you can see CD vector as a subtraction of flow compensated sequence and an uncompensated sequence. In phase contrast phase difference PCPD angiographic display, phase difference phi forms the signal intensity. In multi-channel PC-MRI, as you can see, we have 6 channels in figures. Each channel is acquired as 4 partitions. Each partitions correspond to the reference and pairwise encoded data, and after performing necessary calculations, we obtain the PCCD or PCPD speed images. For my MATLAB simulations, I used a simple dataset of a cylindrical object, assuming its axis in the z direction. For different partitions, I shifted the signal. For complex difference case, here you can see 4 different signals for 4 different partitions in first channel. Then by using these partitions, I used MATLAB to calculate CD speed signal of first channel. Here its X, Y and Z components are shown above and CD speed signal is shown below. After repeating same procedure for all channels, I obtained 6 CD speed signals, and finally by adding them, resultant CD speed signal is illustrated here. For the phase difference case, I used the same signals for partitions and separated their phases. Phase components of first channel in different directions are shown here. Again, by using these components of MATLAB, I obtained the PD speed signal for the first channel. After repeating same procedure for all channels, I obtained 6 PD speed signals, and finally by adding them, resultant PD speed signal is illustrated here. Here is a real-life MATLAB simulation with real data obtained from a volunteer. Imaging was done on a Siemens 1.5 Tesla machine with 6 coils and 64 slices, and another with 7 coils and 64 slices. Here, TE value is chosen as 9 millisecond, TR value is chosen as 56.7 millisecond, flip angle is 150 degrees, and velocity encoding value is 10 centimeter per second. As a result, here are the vessels of a person's brain. Thank you for watching.